In this video, I'm going to teach you how to use R's probability functions. So here I'm in RStudio. I've opened up RStudio, and I'm clicking on the top left-hand corner. There's a little plus, and go to R script. So I'll start a new R script to record what we're doing. So goal, introduce R's probability functions. So the reason we're doing this is because it's year 2020 and we don't really need to look up tables anymore. We can just compute things directly. So this is how I would compute a probability if someone asked me to do it. So here's what we have in our book. We write things like this. S is distributed as normal, say 10, 3 squared. So this is how we would express in our text that x is normally distributed with mean 10 and standard deviation 3 using our textbook. So we might ask, what's the probability that x is less than 10? So the normal distribution is symmetric around the mean. That should be equal to 0.5. We can answer this question in R using P norm, and I'm looking for 10. So this is where we're evaluating the probability. I'm saying that the mean is equal to I don't want to do a normal 10. Let's do something different. Yeah, 10. Okay, 10 is fine. Never mind. So P norm 10, mean is equal to 10. Standard deviation is equal to 3. Okay, now we want to run this line. So I wrote it in the text editor, and I can just go over here and click run. So this equals 0.5 as we expected. So here's how we calculated it. No need to use a z-score and look up a table and all that stuff. We can just do it directly. So that was one example. But here's the general structure for these functions. They take a prefix and a suffix. So the prefixes are as follows. So here the prefix was P, okay, but the other prefix we could have is D. This is for the PMF, probability mass function, or for the PDF, the probability density function. The other prefix we just used is P. That was for the CDF, the cumulative distribution function. Another prefix we could use is Q for the quantile, which we haven't explained in class, but we can do that later, or ask me if you're curious. And R for generate random samples from. Okay. And the suffixes, and I'm not going to show you all of what there are. So these are all the prefixes, but I'm just going to show you some of the suffixes, the ones that we've covered in class. So here's what we have in R. We have binom, size equals 1. This is one possible prefix. Prob equals P. So in our book, this corresponds to Bernoulli P distribution. So this, on the left-hand side, I'm making a column here, that's R, and this is our book, NVIDIA version 5. Besides binom, we have binom with size equal to N and prob equals P. This is Bernoulli, not Bernoulli, binomial, N and P, because Bernoulli is a special case of binomial when n is equal to 1. We can understand it as that way. Then we have another discrete one is Poisson, rate equal to lambda. In our book we have Poisson lambda. Now what we were just doing up above in this example, this p norm, the suffix in this is norm. So the suffix here, norm, with mean equals mu, SD equals sigma. So this is normal mu sigma squared. So note the difference in parameterization. R just takes sigma, but our book uses sigma squared. So in general, some other distributions like the gamma one can possibly have a different parameterization, and if so, you need to be careful, make sure you have the right one. We also have done exp, rate equals lambda, and this is the same as what we have in our book, exp lambda. It's an exp lambda distribution. So then, we can use all these things if we want to find, we take x distributed as, say, binomial 20 and with p equals 0.07, something like that. We want to find the probability that x is less than say 13. Okay, if you do this by hand, this is really hard to do this is a big pain to do by hand. So we don't want to do it by hand. We can ask it directly in R. So in R, you just write we're using the CDF now, so we're doing P is the right prefix, so that gives us the prefix. The suffix is binom. Size equals 20 here. Probability equals 0.07. Okay. I run this line now, and oh, I didn't do the actual 13. I forgot to put the 13 in here. Okay, so no big deal. Put the 13 in. Probability that x is less than 13. Run this line. It's 1. Okay. If we change this probability, we can change this up. So instead of 0.07, we'll say 0.7. Probability that x is less than 13. Okay, so this is something completely different. We didn't have to do a bunch of calculations. We just changed the parameter here and we got the right answer. Okay. All right. So these are the sort of questions you can answer, and so now you can answer any kind of question you want about any of these distributions that has to do with probability. So for example, if we want the probability that this same x, and I'll change this, we're at 0.7, the probability that x is or that might be less than or equal to, huh? This is less than or equal to 13. The probability that x is greater than 13 now, we can just do arithmetic on this. It's the opposite of that. 1 minus the probability that x is less than or equal to 13. Run this. We can answer those types of questions too. Okay, so you can get very into all this, as you might expect. Here's something I did, like this is what you'll see in the books typically, so I wrote another file that has some plots with the probability density functions. I run this by putting source and source the whole script, run every line in there. These are the graphics that you'll find in your textbooks, but you'll notice that these graphics, they can be even better than the textbook. R makes really nice graphics, so it's a good way to go for that. And here you can see what happens when you change the rate parameter for an exponential distribution. You get different kinds of shapes, different kinds of PDFs, that is, probability density functions. If you want to get more into it, there's all kinds of resources out there. For example, this probability functions in R. I just did a quick Google search and found this. And also, if you don't want to install RStudio, but you still want to be able to evaluate these kinds of functions, I just copy and paste here, and we have demonstrated this rdrr.io snippets. You can just run little bits inside here and see what these answers are without having to install R.